Hello, my name is Christopher Tate. Once you have your own domain name and valid SSL certificate, you can start running all your web applications with your SSL certificate for trusted connections. This includes the OpenShift web console, as well as all the routes to your applications in OpenShift. Pretty cool, right? To get started, if you've not already purchased your own domain name and created a valid SSL certificate, then check out the links below. If you have not yet installed OpenShift, you will want to start by installing Docker on your system. This assumes that you are running RHEL, CentOS, or Fedora. You can install Docker like this. We'll do a sudo yum. Let me make this bigger. It's too small. Sudo yum install -y docker. Enter my password. Okay, here it goes. Okay, it's installed. But there's a bunch of other steps we need to do to prepare Docker. And these steps get a little bit complicated. So in the video, below the video, you'll be able to follow along and enter the commands. You can see the commands below. So this one is going to allow insecure registries in Docker for storing your Docker images in OpenShift. So we're going to run that to create this file to allow insecure registries at 172.30. All right. Now there are some firewall rules to apply permanently to add all IP addresses in the 172.17 range to be in the Docker C zone and then reload the firewall. So we create a new zone called Docker C, and we can add this source to it permanently, add a port to it, add the port 53, the port 8443, the port 8053, and then reload the firewall to apply all of those. Cool. All right. Now let's start Docker. Let's enable it as a system service. So it'll start when the computer boots. And then start Docker here. No complaints. And we'll see if it's running. Yes, it's active running. Good. Okay, moving on. So now that Docker is installed, you can download the latest OpenShift version 3.9 client, Linux client here. Okay, so follow this link here. Log in real quick. then scroll down to the OpenShift v39 Linux client, and we'll download that now. Save it. And that'll take a second. All right, so then we will, okay, so this is we're downloading a compressed file containing the OC binary. And since OC cluster up runs as root, and other OC commands need root privileges to access certificates and other things only readable by root, I like to put OC binary in root's path, like this. So we're going to extract it with tar, should be in my downloads, and put it into user/usr/bin. There we go. Now if I do which OC, we see it in user/bin. Cool. We'll use that later. Now we want to create some directories for persisting OpenShift configs, data, and volumes, like this. You got these three directories. You can put them wherever you want. I thought they'd fit well in /var/local/oc-3.9/ and then there's a host config directory, a host data directory, a host PV, and a host volumes directory. So we need all of those, and we'll put them all together like this. Okay, so this could allow you to run more than one OpenShift version if you wanted. Or at least, I don't know. 3.9, it lets you upgrade your OC version between 3.9 if you want to, because new versions come out all the time. But beyond 3.9 would be like a major version of OpenShift. So anyway. So now for reference in several commands below, you will want to specify your purchase domain name in an environment variable. For example, example.com. But for me, it's going to be, let me change example.com to heytate.com, because that's the domain I purchased in the earlier videos. And I created the SSL certificate for it. Okay, so I got that, and then based on that, I'll generate these other environment variables. Let's just take a look now. OC domain name is heytate.com. OC web console host name is openshift.heytate.com, and routing prefix will be apps.heytate.com. So OpenShift.heytate.com is where my OpenShift web console will be running, and everything under apps.heytate.com is where my routes are defined for my OpenShift container applications. All right. So now there's a tricky little step to include the Red Hat repositories in Docker. And the first step is to obtain the redhat-uep.pem file from your existing laptop on the same network as the computer on which you are trying to install OpenStack. It's a file with some certificates in there that are needed for Docker to be able to pull down these images. So, for example, my Red Hat laptop with a local IP address of 192.168.1.6, I'm going to rsync that file to my local. It asks for my password on my laptop, and I got it. So then I just need to make this specific directory here, /etc/rhsm/ca, and put that file inside. So we can do that here. Make sure still have sudo. Good. All right. So now there's my file. Cool. A couple other things. We need to register the registry.access.redhat.com registry in Docker. And we do that with this. We create this registries.conf file in this specific Docker directory /run/containers. So do that here. Good. And we also want to add this Red Hat specific container content plugin.conf to enable more registries as well. So we can do that with this command here to create that file and directory. Great. All right. So now we are going to run OpenShift for the first time. We'll download a bunch of dependencies, which takes a while. Anyway, but this should start up pretty quick. I have the dependencies loaded already. Okay. So we do a sudo because OpenShift has to run a sudo root, cluster up, bring up the cluster. We put in the routing suffix so it knows where the host names for the apps. We'll enable logging and metrics. We'll use an existing config so that our OpenShift configuration is persisted between starting up the times you start up OpenShift. It's persistent. And we specify the host config dir, the host data dir, the host PV dir, and the host volumes dir. We created those earlier. Okay. And we specify the public host name as the OC web console host name, which is openshift.tate.com for me. And so that's what the parameters are. And now we just wait. Oh, fail. Okay, let's try this one more time. Oh, it's already running. Yay. Okay, so I wouldn't worry about this. This probably has to do with host names and the fact that we specified this public host name, and that public host name is not in our /etc/hosts. It's not resolved through DNS. So that should be fine. We can still open it up here by going to https://openshift.tate.com /8443. It's the default port for the web console. All of the apps run on regular 443 with OpenShift. and the web console runs on 8443. To get the web console on 8443, you'd have to do some fancy proxying, which I'll go over in a future video. But for this, we're not going to worry about it. So here, yeah, we haven't resolved this host name, and so we need to add that. When you specify a public host name, then you need to have DNS be able to resolve that host name. If your OpenShift application were publicly available to the web, which it probably shouldn't be, then you could use your domain registrar to register a DNS-A record for your public host name and a wildcard DNS-A record for your routing suffix routes. But since this is likely an internal OpenShift application local to your machine, then you want to do some internal DNS. It's possible to set up an internal DNS server with the Red Hat IDM application or a community free IPA application in a virtual machine, which I'll show you how to do in future videos. But for now, the quick and dirty way is to add entries to these host names in your /etc/hosts file for now. So add your public host name to your /etc/hosts like this. Just for backup, we will print out what it was before, which is basic. And then here we can update it with this fancy Perl command. And what we get is OpenShift.heytate.com at the end. So now, when we go back here, instead of spinning in circles, this resolves and it says insecure connection because this has the certificate. Well, anyway, the certificate is no good because it's just a self-signed cert. So we're going to fix that. Okay. Next. Here we go. We need to take the certificate and key we got from certbot and copy it into the OpenShift host config master directory. These paths may not be exact depending on where certbot put the latest certificates, but let's run these here. Okay. That one and this one. So we're copying the certificate and private key to this host config master directory. So I should be able to find sudo ls wildcard.star. Yeah, so I've got those there. I got my cert and my private key. So when OpenShift started for the first time, it created a configuration file, host-config/master/master-config.yaml. We can update this file to specify the certificate and key for the web console. First, back up the config file, just in case, then update the root serving info named certificates section like this. Just to show you, I'll show you what it looks like before. Let's do a little backup. Okay, and then I'll show you what it is before, which is serving info : name certificates null. So that section's empty. So we're going to populate it here with this fancy Perl command here. What we get instead is name certificates with the cert file of wildcard.server.cert, which we placed earlier, and key file of wildcard.server.key with names OpenShift.Tate.com. What this is it says if you get a request to OpenShift.Tate.com, then use these certificate and keys. So, cool. So we set up SSL for our web console at this point. Now we're going to secure it for our routes. So to update the routes, we need to update the default router pod of OpenShift. For this, we will log in with admin privileges by referencing admin.kubeconfig file. For this, you will want to run all these commands as root, since the files like admin.kubeconfig are not accessible except by root, and you need to be able to log into OpenShift as root. Anyway, so do a sudo -i, and now we're root. Now we will grant cluster admin privileges to the admin user, log into OpenShift as admin, and make sure we are on the default project. Okay, so here we go. I added a cluster role to user called cluster admin to admin, and this is like the password to be master. Have master privileges to OpenShift. So, did I say admin privileges to OpenShift? That's what I meant. Okay, so admin now has admin privileges, and I can log in as admin and put in any password here. And there are the admin projects. Yeah. Okay, we gotta make sure we're on project default. Okay. And then we are gonna obtain the Let's Encrypt CA intermediate cert here. And we're gonna put it in a Let's Encrypt x3 cross-sign cert file in hostconfig master. So let's do that. Grab that command. Put it in. Okay. Now we can generate a PEM file that consolidates our wildcard key, our wildcard cert, our wildcard key, and our CA certificate all together with a command like this. It's kind of long, but it just includes the cert, key, and the CA cert and puts it into a PEM file called wildcard.router.pem. It could be named whatever, but that's what I named it. Okay, next we need to give the router permissions to host network, create a new default HA proxy router, and which is a pod, and create a new router service account with the wildcard.router.pem file. So we do this one first. Okay, so the router can access the host network now, which is great. That's what it needs. And then we create this router in OpenShift and add a default cert to it. Okay. And it says it already exists. So that means that it's set up with the wrong cert. So let me show you here. Okay, so I'm going to add an exception and confirm. Okay. Oh, right. 8443. Let's go there. Okay, there we go. Now we're in. We can go in as admin and see the admin stuff. And here it is, the router. And the router has some configuration here with a secret called router certs. And this secret here is out of date. Well, I mean, it's the self-signed cert. So we're going to change that. We need to update it. So that's what we're in the process of here. Okay, so we are going to back up those old secrets just to be super cautious. And then create the new secrets based on the PEM file that has everything in it. And we specify the key as well. And make a dry run of that, but pipe that directly into a replace of that object in OpenShift. So it goes and replaces that secret. So that's up to date, but the documentation tells us that we also need to re-annotate the secret here. So this removes the annotations with this minus sign on these, and then it adds it back with that command. It's very similar, but the first one has minuses on these two things, and then the next one doesn't, and it only has one of them. So then we can roll out the latest router, which means that this router is going to be redeployed here in OpenShift. You can see that here. So let's just watch how this goes. So far, so good. This turns darker blue, and we're in luck. Yeah. Okay. This is really exciting. Okay, so now we can exit root, and now if you have errors, then you can bring the cluster down and back up again, but we shouldn't have to worry about that. Everything's looking good. The router pod went up, but we're going to bring it down to do a little extra special sauce. Because I want OpenShift to be a system service that starts automatically when the computer starts. So we echo this service file that has some description. It says it starts after Docker. It runs as root, and it has the same exec command that we were running earlier to start up our cluster with all the persistent directories and config and stuff. It tells it how to stop it, and that we don't want to restart it, and how to output to the logs. Anyway, so all of this will create a system service, and then we can reload the systemctl daemon and start and enable OpenShift. This takes a couple seconds. Okay, and it's enabled, and let's check the status. Yes, active. Cool. Okay, so then this is the URL here, so we'll go straight there. Again, okay, so notice before we had this security exception, self-signed cert. Let's go again. Oh man, we have a secure connection to OpenShift, verified by Let's Encrypt. And, okay, so now we're going to deploy, let's see, I'm going to log out of admin. Okay, and log back in as developer. All right, now I'm going to create a basic project like Jenkins. Jenkins is pretty easy to do. Okay, so let's call this Tate. Jenkins, and create that. Create anyway, close. All right, so then it has a route for us. So I'm going to copy that. I'm going to make sure that that is in my to-do vim etc hosts. Okay, just need to strip off the slash and this stuff. Okay. Let's see how our Jenkins is doing. It's almost ready. So excited. You ready for this? Whoa! There it is. Our application running on OpenShift, and it's secured by Let's Encrypt. Yeah! Now you can do a little dance. Yes, 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 yes. All right. So, I made an appendix. You can update your certificate at any time using the same commands you did earlier. And so there you go. You got go get your domain name, go make your SSL certificate, and get your OpenShift running securely, verified by Let's Encrypt, and do a little dance. And I hope you enjoyed this video. Thanks a lot.